Okay, so as we look at module 2, you're going to notice there are 2 things to hand in. So if you haven't been listening, come back to me right now because I'm going to be going over the requirements for the assignment and hopefully answering any questions that you might have. So the 2 things you're going to hand in for module 2 is going to be the practice problems and assignment number 2. So let's look at the practice problems first. You're going to notice the practice problems coincide with the things that we went over in class. So example 3, 5, 10, and 11 were from the first lecture that we did the last time we were together. 16 and 17 vector equations were what we did today. Okay, so screenshots of each one of these with the equations, with everything labeled, your origin, and then any missing information, whether it's finding a resultant or if it's finding an unknown quantity like we saw today within an equation, make sure that you label those with dimensions. You're going to be submitting your screenshots. So make sure that when you do your screenshot and you add it to whatever document you're uploading, that I can see it. Okay, that I can see the numbers and make them out. If I can't, unfortunately, I can't give you credit. Okay, so a couple things to keep in mind. Label each vector, add arrowheads to all the vectors, identify the vector equation, and scale the dimensions so I can see them. Dimensions and labels, actually. Okay. And then here too, just highlighting, be sure it's readable. I can't, I hate giving zeros when it's for that. So, so just take that little second before you hand in to check the file, okay? Then I want you to, as part of that file, to answer me the 2 things that you learned in this module with vectors. I know you've learned about vectors before, so some of this was probably new, but some of it you've done before. If you've had me for statics, which most of you have, we did vector additions and resultants in statics, right? But vector subtractions, as far as like in the program, I think that might have been new, as well as the equation stuff that we did towards the end here, okay? But I also want you to identify things that you might need additional practice on. Always know that when we look at the assignment, it's going to be then, you know, more of reinforcement and application of what we learned in these examples. So through that repetition and that practice, that's my hope, is that that'll be enough for you to feel confident at the end. But if it's not, or if you have questions as you go along, that's what I'm here for. Okay. So practice problems. Any questions on practice problems here for module 2? Okay. So then let's go back and look at assignment number 2. Okay, assignment number 2 is going to be problems from the end of chapter 3. Okay, and there's quite a few here. All right, so there's a little bit of work. So let's go to, we're starting with 20. Let's go to page 69. Page 69. So I'll go underneath here. The first problem that you're going to do, it says, for the vectors shown in this illustration, A and B, graphically determine the resultant. So A plus B. So vectorially add these 2 vectors together to find the resultant. So make sure then when you identify your vector diagram, add this equation in your diagram so that I can see that you're adding them in that order. Identify an origin, and then make sure that you label and add a vector and the a dimension to the resultant. Okay, because it's asking what is graphically determine the resultant. To fully define a resultant, I need both magnitude and direction. So don't just put magnitude in there, or just the dimension of the length. You have to put an arrowhead and then a length if needed. Or I'm sorry, an angle if needed. If it's something other than vertical or horizontal, you have to add an angle from vertical or horizontal. Does that make sense to everybody? All right. The next one that you're going to do is number 23. Here you've got 1, 2, 3 vectors this time. You're going to add them together, A plus B plus C, to find the resultant. So very similar, except now you're doing 3 vectors instead of just 2. Okay. When you do your vector additions here and you show A, B, and C, you just need to label them A, B, and C. You do not need to add the lengths of each one or their angles. It's going to get too busy. So your final answer is what you add the dimension to, which is going to be your resultant, arrowheads, as well as an angle. Okay, that's the thing that you're going to be dimensioning. You don't need to add the dimensions. Label A, B, and C. but the assumption is if you get the right answer, then you did it correctly, okay? Then your next one is going to be 25. All right, so here you have, it looks like 5 vectors that you're going to add together to get the resultant. I don't know why it says ES there. I think that's a typo. So vector E is vector E. I don't know why I think it's just, like I said, I think it's a typo. The S is there. So if you're wondering, it is of no significance. All right. Then what we're going to do is we're going to look at number 32, and it says for the vectors shown in P320. So those are these 2 vectors right here. For these 2 vectors, you're now going to find J by taking A minus vectorially B. So that's a vector subtraction. All right. Then you're going to turn the page. Number 44. This one is going to be using the next diagram. J equal to C plus A minus B. So number 23, you've drawn these 3 vectors. Now you're going to use that vector equation with the subtraction of C. Okay. And then you're going to do number 25. So 48 and 49 are utilizing the same from 25, which you also drew the 5 vectors for, but now instead of a vector addition, there are 2 vector subtractions here. Okay. I encourage you when you use when you do the vector subtraction is to add the negative value. Okay, so make sure that you draw the equation or you identify the equation like you're adding the negative version of C rather than vectorially subtracting. Does that make sense to everybody? That way you can do the tip to tail, and then it's just the arrowhead is on the other side. All right, then the last 2 problems that we have are 58 and 59. And as you can see, these are going to be similar to what you did for the last 2 examples that we did in the last part of the lecture. So this is going to be like 16 and 17, example 16 and 17. So here you're going to notice here's our base equation, and they want us to determine the magnitude of C and E. So C and E are right here. So they're giving you their line of action, but you've got to determine what's their magnitude, and is it going up and to the right or down and to the left or right for E, okay? And then you're going to see that down here, you've got, then again, 2 unknowns, D and F. Do you need to do any work to rearrange? Remember, the rules are you can't have more than 1 unknown on any given side. You can have 2 total unknowns in an equation, which we will for each one of these. Make sure first that they reside on either side of the equal sign, and then eliminate as many negatives as you can, if you can, okay? Sometimes through that process of separating them by the equal sign, you got to live with one being negative like we saw with A in our one example. Okay, so that's an overview of the assignment. Let's look back at Canvas. So that's all of the items that you have. I do have for you an answer key here, all right? This comes in handy because that way when you get to the end and you find your resultant or you find your J or your K, did it come out right, right? You know, just to make sure. So I do have those for you here, your final answers on each one of these, okay? So if you wanted to take a peek before you move to the next one, that's a good idea. The other thing I want to let you know is that all of these angles are from standard 0 moving counterclockwise. Does that make sense to everybody? So for this is, 92 degrees. That means from vertical, it's 2 degrees counterclockwise from that. All right. In some cases, you may not be able to put the AutoCAD angle in. That's okay. That's okay. If you get beyond 90 degrees, I don't think the dimension will put in the full from 0. You know, there's some that it won't. I don't want you to spend time trying to make that work. There probably is a way in the settings on doing that, but you don't have to. Okay. Then just measure it from whatever the closest horizontal or vertical line is. Okay. and make sure that if you were measuring it from standard 0, that it would be that value. I think it's like something like, oh, like the 348.6 degrees. AutoCAD will do the acute angle. It won't go from 0 and go all the way around. Does that make sense? And like I said, there might be a way in the settings somewhere down deep, but that is not the focus of this class. Then just do the acute angle from 0 and then go clockwise down to whatever that would be. Does that make sense to everybody? All right. Because I know some people are like, oh, I can't get AutoCAD to put that angle in. This is just to let you know if you're okay. All right. If you do have discrepancies, then just like I did in my example, 317, or was it whichever one it was, go back and check all of your lengths and the angles, and you probably are going to find somewhere along the way you keyed something in not quite right. It happens. Okay. So, but these I know are tried and true. The answers are correct. So if you are having problems getting those and you troubleshoot, you can't figure it out, that's what I'm here for. Okay. So as we look at the assignment then, just as a review, you're going to be submitting screenshots, making sure that you include everything, make sure that it's readable, okay? As you know, you don't have to convert to a PDF. It's always kind of the safest way, but if you leave it in a Google Doc or in a Word document, that's totally fine too. I can see those as they come up. And then that's it. Are there any questions on the assignment? Okay, then I am going to stop recording.